everyone. I'd like to introduce our panelists. First, we have Dr. Yang Gao. She's a professor at the University of Surrey and the founder and director of AI for Space Limited. Next, we have Dr. Armin Wedler. He's from the German Aerospace Center, Institute of Robotics. Hi, Armin. And then Dr. Ali Agha. He's the founder and CEO of Field Robotics. And we have Marco Pavone, professor at Stanford University and NVIDIA. So the purpose of this panel is to discuss, as AI and robotics are accelerated, and we expect to have a lot more development in space, how we can sort of have leadership and policy for space, sustainable space exploration. So I was going to start with asking the panelists to comment on this, and then mostly we'll spend our time letting all of you ask questions after that. So starting with Dr. Marco Pavone, how do you think AI is impacting how we architect robots?
Thank you very much for the questions. I'm very happy to be here. So it should be no surprise to you that AI is completely transforming the way we architect robotic systems. It's changing, for example, the way we architect the autonomy stack of autonomous cars in all its functionalities, from perception to decision-making to prediction and so on and so forth. And this is great because it's basically dramatically improving performance of these robots, and it's also dramatically reducing the development cost. Now, instead of having many hundreds of people, engineers, really fine-tuning by hand, so to speak, your stack, you can rely on data and automatically train a machine to accomplish a given goal. Now, of course, that means that the technology development is accelerating significantly, but that also begs some questions in terms of how sustainable this acceleration is. For example, we were discussing earlier on with the other panelists what that means, particularly in the context of space exploration for environmental sustainability. If you're going to have many new developers of space systems, and we're going to have many space assets in orbit, what are the implications? Or operational sustainability, how do we coordinate many different stakeholders that might be enabled by this new technology? Financial sustainability, how do we sustain such a growth, and so on and so forth. But I'm sure that we have more time to talk about these aspects later.
Thanks, Marco. And then I was going to have Dr. Yang Gao comment on what your vision is for sustainable space system design.
Sure, Wendy, thank you so much. Hello, everyone. I think that's a very thoughtful and forward-looking question, because at the moment, in fact, the past and current mission system design are principally looking at missions that might have very fixed and limited lifetime, and they tend to be one-off missions. So the designs are not necessarily need to be sustainable. But looking into the future, things are going to change. The expectation is spacecraft, space robots, space systems in general need to be built very sustainably, because their goals is to support or achieve more long-lived presence in space for humanity. They need to support systems and infrastructures that has a long duration. So this would require technologies that can enable very robust mobility, very robust autonomous capabilities. Just to give the audience a few tangible examples, for instance, as Marco already alluded towards, we need sensing perception in very extreme space environment that is dynamic changing, and we need to do those sensing at low computation but very high accuracy. We also want locomotion system that is very energy optimized. We need data assimilation for parameter tuning, particularly if with introduction of machine learning, AI techniques. And also sustainable design involves reconfigurability of both hardware and software. And we want self-diagnosis and self-certification of algorithms, particularly using AI techniques, so that we as the society and the general public would feel confident there is trustworthiness of the AI that's being used on those critical systems. So these are just a few examples, hopefully help stimulate some of the new novel ideas and the discussion later on.
Great, thank you. And then Dr. Armin Wedler, I was going to ask you about, you worked on the gap assessment report, and that's particularly trying to accelerate technology transfer into missions. And so if you have any thoughts on that.
Yeah, thank you, Vandi. And the gap assessment report was made from the ISAC, the International Space Exploration Coordination Group, and I would say that's a common understanding of nations of what is missing or what is the plan for the future for space exploration. And there was an accumulation of all different nations' plans for next space missions, and put that together into an assessment, what for autonomous driving, what in our days we are experiencing, what Marco is referring to. For example, NVIDIA is developing for the streets on our Earth, and also what Yao has mentioned too, is missing. In this report, we try to elaborate that things which said already, like computational power, very resource efficient computational power architectures are missing on a space grade level. I think there's a lot of ongoing activities, but this is very individually in companies or in different nations happening currently. We have a lack of perception capabilities, so as we all know, cameras are a baseline for actual perception. I think lidars, as we all know from autonomous driving, are not existing in the quality as a space-grade lidar system. So an active perception system, I would say, is currently missing, which would allow us a lot of more autonomous functionalities, which would allow us to implement more AI technologies we are currently seeing entering day by day in our Earth life.
Great, and then I was going to have Dr. Ali Agha comment on the role you see our commercial partners play in AI for space exploration.
Yeah, hi everybody. In general, I think it's a pretty exciting time for space exploration, and I think commercial partners are playing a more and more important role as we move forward. We see the transformational role SpaceX, Blue Origin, and a lot of other companies are playing. The number of launches are getting more and more frequent. But from the angle of maybe sustainability and AI perspective, I would say probably two areas that would be impacted most in the near future. I would say the first one probably would be environmental monitoring. Earth observing satellites, they collect massive amount of data, and a partnership between space agencies and commercial partners, where commercial partners come in and analyze this massive data based on the infrastructure they have had and they have been building for various different sectors, such as self-driving cars, such as a lot of different areas that are big data is common. I think that would be a very common and natural partnership there that would help space exploration from commercial perspective. And second one probably would be more on the angle of long-term habitability. As we are going more and more towards missions that would put astronauts and robots to operate for extended periods of time on other planets, Mars, Moon, and so on, I think it would become more and more important for commercial partners to come in and use AI solutions to build, AI-powered, sustainable houses, places in other planets, manage energy, manage compute power, and things like that to enable basically long-term presence on other planets.
Thank you. So now we were going to open up the questions to the audience, and I don't know, do you need one of the mics? So if you have any questions, maybe raise your hand and come by. while the audience is thinking, I will ask a question. So, oh, there is. Go ahead.
Hi, thank you for the very interesting presentation. My question was, you mentioned that the LiDAR technology is not currently used a lot in space, right? What are the limitations of this technology today, and why is it not more used as we're using them on cars today?
Yeah. Maybe you can start. I don't know if others have to refer to it. I think current LiDARs, as we are seeing it around here, like mentioned a company like the Velodyne system, which have millions of points, have a lot of moving parts inside. So it's a mechanical, electronical device. And to make that stabilized in thermal environments like in space, functional in vacuum, there's just a lack of money, I would say, for these companies to motivate them to do such a risk. So it's no qualified LiDAR. There are LiDARs, line LiDARs existing, even simple systems, but having these environmental LiDARs, which we all now are using in, for example, car automatization, that systems not exist. So there are some promising developments in solid-state LiDARs in such systems, which I could believe in future could be qualified easily. But I think it's not a lack of technology, it's a lack of that this, let's say, knowledge is owned by companies, and the space market, Ali have said it, it's growing, fast growing, and I would say there's a lot of potential in the future, but for now, it's not the mass market. So those companies are not, let's say, motivated enough to develop a space-graded version. It's same for chips and high computing power capabilities. Does it answer your question?
Yeah, and I'd just add one of the things also is mass to space is critical and power is very limited. And especially for some of the existing space missions, the reason cameras are used more is they play a dual purpose. Humans can look at it, scientists can look at it, but there's definitely room to have low power, efficient, future LiDAR applications that will certainly improve our detection of, for example, sand and other features. Is there another question? On, so AI, role of AI for sustainable space exploration. Otherwise, I'm going to ask the panelists if what your view is for the global vision for AI for sustainable space exploration. Armin, did you want to comment on this?
Sure, I'll start. Yeah, I mean, my personal view on that, which refers also to, let's say, the Global Exploration Roadmap, which is, again, this common agreement on what's going on. I think we all agree to build up a permanent base and make other planets permanently existence with a human presence. And I'm saying we are all approaching to that, all nations worldwide. And that vision in sense of AI and sustainability and resource conservative habitats, I think we all need to look to have a sustainable communication. We need to be over nation, cooperative, and we need to have also legal agreements together in that manner. And I think my vision, and I believe that this will come true sooner or later. There are some space companies which talk about next 2 years. I don't believe in that so fast, but somehow, maybe at the end of the century, we might be having a permanent lunar station, which is maybe not fully equipped with astronauts the whole year, but somehow there is this lunar gateway which will be in existence by the end of the century. And I believe that this is a vision we should all. In my business in space, that's very motivating because that's showing a perspective. Some industry partners using this vision also to attract a lot of people now. But I believe it comes true, and I'm also very positive in looking such a future that we are, as humanity, work together and building such a interesting and future-oriented infrastructure.
Thank you. Marco, did you want to add anything to that?
Yeah, I think human presence in the solar system, particularly on the moon, is super exciting, but it's not the only exciting things that I see for the next few decades. For example, I've been always passionate about the Mars program. Actually, I was working in the Mars programs with the Mars program with Vandi when I was at JPL. But now we're looking at other, possibly even more ambitious targets, like, for example, icy bodies, moons such as Enceladus of Europa, that are farther away than Mars, and they require robots to be able to possibly penetrate ice crust and explore environments that we don't really have a clue about what they look like. That really pushes the need for autonomy and AI to the next level. You really need to have systems that can adapt, that can reason, that can perceive in an unprecedented way. And beyond space robotics, I think one of the grand goals for this century is the fact that probably for the first time, actually probably for sure, for the first time in our history, we do have a chance to pinpoint and estimate whether there is other life in the universe. By looking at the exoplanets and the processes in their atmosphere, we do have an opportunity to conclusively say whether other planets outside of the solar systems do sustain life. And again, this requires tremendous advances in a vast array of space technologies, including AI as well. So bottom line is that the vision for the century, I would say, is extremely exciting. It goes from a permanent presence of humans, for example, on the moon, to explore very remote environments, to actually look at signs of lives beyond the solar system.
Thanks, Marco. And then, I was going to, if anybody has a question, just raise your hand and they'll bring the mic to you. Go ahead.
Thank you. So I just wanted to say this is all super interesting about how AI could be used in all these exploration kind of situations. My question would be more on the sustainability of basically the vast majority of missions and projects which are done, which are in LEO, MEO. So how could AI essentially help us in avoiding basically a Kessler syndrome event from happening around Earth?
Yeah. Do you want to?
I just want to clarify the question a little. You talk about orbital missions in the LEO and GEO, and the question is more about how AI will impact those missions, or a bit beyond.
My understanding is that, okay, we're asking how these AI-powered devices are going to help us do exploration and exploitation, and so my question is, how will those kind of processes help us with what's happening right around the Earth? So if we want to be able to do all of these missions, like, we need to be able to go into space from Earth, right? So
Yeah, I think AI, just speaking from my personal experience, I'm saying it as a family of technologies that is contributing to different stages of a space mission. I think you rightly pointed out, it started from the launching up to the transportation, to then operation in orbit, and it also potentially involve sustainable operations such as servicing. So you can stay there getting things repaired if something goes wrong. And there's also recycling involved. There's also issues such as space debris capturing, removal, recycling, and that whole life cycle of space exploration, exploitation, and this certainly extended to beyond Earth's orbit, to translunar and deep space. So indeed, I'm saying AI as a family of technologies, range from the computing, like involving machine learning, up to involving AI in the embodiment of the hardware design as well. So they are playing critical roles. I think in the long term, we will be seeing a lot of AI being introduced to the design at the very beginning. of the space systems. At the moment, as you would probably appreciate, we are going through a transformation from more classical ways of design space system to embracing these new techniques. And that transition time sometimes need us to learn sometimes from the mistakes and experiences. I think in the long term, as I can see as academic and innovator in the area, I think we're seeing some kind of a brand new mentality. So for instance, you will be designing software system from the very beginning that is we call almost like a AI is embedded in the DNA of that software. So you can introduce learning, you can introduce all this capability that AI can offer at the very beginning of the system development. I think in the long term, create an ecosystem. We call it the ecosystem that involve this kind of very powerful capabilities.
Thank you. And also, I think one part of your question was the sustainability. We have a lot of spacecraft in low Earth orbit, and some of them take repeated measurements, and there's a lot of characterization. You're trying to look at how the impact is on sort of global climate. And for something like that, AI is very suited because you can, over a long period of time, correlate observations. You can also respond to certain things you see in your sensing and say, I notice there is this change here, and I need to make this sort of observation. So you're dynamically changing the controls and perception. And I think this way we can make observations and create models that help us better understand just globally, how our actions are impacting things. Did you want to?
Yeah, I would second what Vandi's saying. Basically, I think the impact on Earth would be massive, right? From pollution to global warming to fire management. A lot of things we can see from Earth observing satellites. And there are two elements there. These are typically spatiotemporal events, right? You want to measure at different locations, but also you want to measure over time. And I think the time has always been there, as Vandi mentioned. And what is changing a lot now is that because we are launching a lot more, rockets and basically satellites now, with the commercial help from the commercial side. So there will be a lot more satellites at different locations, which would help us to create these models, would help us to much more precisely predict the future of what's going to happen and react to them in time. But that means you have a lot more data to deal with, and we are traditionally, with traditional classical methods, are not prepared for that. So AI would play a very critical role there to assess that data, extract trends out of it, learn, and that's something on Earth, on terrestrial application, has been done in many different application domains with very large data, but that gap needs to be bridged, and AI come and actually analyze the data coming from these massive number of satellites.
Thank you.
It just can refer to an exhibition show up there. I think on the first floor there is a little stand. It's from the World Food Programme and Google together, how they use satellite data imagery to detect and analyze, let's say, on huge data sources, predict growth of crops, predict damage in flooded areas and this kind of situations. How AI is used, you can just have a look over there, and I refer to that.
Thank you. Listen.
Hi, thank you so much for being here and talking with us about this. It's a really important issue, obviously, and so I'm wondering your thoughts on how AI is going to affect the timeline that's expected for private companies and governments to deorbit their satellites. Right now, I mean, there aren't necessarily specific timelines that are. But it's more of a general expectation of how long you should take to bring down your satellite. So how is AI going to affect that process?
Just to clarify, is this to do with deorbiting after and the lifetime of
Yes.
each. Sure.
thank you.
So there's some very interesting technology I think we've been investigating. I think AI, for example, are certainly looking at potentially prolonging the lifetime of satellite so that you can reduce or minimize the risk of them becoming space junk. And they're also very active technology development in AI and robotics so that we can, for example, help detect and retrieve some of the satellites. I think in terms of your question, which is I think very critical in terms of time and efficiency related or productivity, I think there is some certainly some motivations with the introduction of this technology. We've been looking at potentially without increasing necessarily the cost of the mission, we can maybe prolong the mission duration. So effectively, you can see that this, I think in a way would improve the productivity and there's a cost saving. In terms of the actual mission that goes actively to collect the satellite after the lifetime, I know, for example, personally, I'm involved in a demonstration mission led by UK Space Agency, looking at launching a mission to go and retrieve the orbit to retire satellite, and we are looking at, in I think 3-5 years time to have that technology being demonstrated in orbit. I'm hoping, I think my other colleague can certainly add their personal experience on this, but I would say that I'm hoping that in 5 to 10 years time, we will be seeing those technologies being a potential service to satellite manufacturers so that can potentially use it, so they can factor in when they actively manufacturing satellite, so they can consider that as a, potential benefit. Hopefully, that would help solve some of the concerns we have right now.
Yeah, and Marco, maybe you want to add, because there's a huge element, there's an element one of planning. So when you launch these satellites, I think we will have a plan for the deorbit, even before you start. I think it's an important one. And the other is actually the tracking, because things can go wrong. And if you leave it up to each company to report where things are at, we could have a better way to actually help that to be done in a way so that you can sort of have a policy that each person abides by that. And Marco, I don't know if you want to...
Yeah, just a couple of additions. So first of all, AI, along with other technologies, allow you to build the digital twins of a spacecraft that allow you to really monitor the health of the spacecraft at level of accuracy that you couldn't do with the traditional methodologies. And of course, AI techniques also now help us with the tracking pretty much almost all of the objects in orbit, so really allow you to optimize the life cycle of a spacecraft, but I would say of all space assets jointly. Again, at a level that was not even possible a few years ago. And there are companies that actually do provide now as a service tracking of your spacecraft in a very accurate way, along with all other potential dangers that might affect the health of your spacecraft. So again, AI is a broad term, so you have a really portfolio of technologies that allow you to optimize the life cycle of an asset.
There's a question over there.
Yeah.
Right over there.
Okay, you can go first.
No. Oh. Thank you. Veronique Claude, I'm from the ITU, and I'm hearing you speaking about AI, space sustainability, and policy. Do you think AI and the data we can retrieve from space could be supporting regulations at international level sometime?
Yeah, I think that's a very, very good question, because I think that is something we want to start the conversation on now, as this is one of the areas in which we can get ahead of the game as the commercial area starts to expand. And it's much easier to put the policies in place and have a discussion about them than trying to be behind that. So I was wondering, Armin and Ali, if you wanted to comment on it.
Yeah, I think it's a very good question, and I might even give an example, just refer to the standard, which already allows a lot of data analysis on huge data sources of satellite imagery, predict food crops and predict other hazards. But I would say one explicit example, I think, and there's a lack on quality in terms of resolution now. It's if we all think about, let's say, CO2 certificates. The CO2 certificate deal worldwide is probably accepted and will be more valuable in the future, or will be more important for everyone. It would be a very good target, I believe, that we are working on explicit methods to, from satellite imagery worldwide, detect, and there was some talks yesterday, I was listening up in the on the main floor, to detect clearly, first, who pollutes where, what, in which amount, but on the other hand also, there are a lot of sources where we can bring CO2 underground in the fields and this kind of thing. That could be observed by satellite with the correct, let's say, equipment. And I think that's in the future, just to be on a concrete example, could be a very good application case for using such AI techniques to handle all this data which comes in, and to make it also, let's say, legally agreed under all these different nations, which probably it's a political challenge. Maybe Ali, I don't know. No.
Yeah, and I think that, you know, you're asking, this is part of the reason why this is a slightly unusual panel to have here, but we really wanted to be part of the discussion, is it is a global topic, and we want to sort of have, with the help of the ITU, provide some leadership in this, so we can start having a discussion on it to see all sides of it, what the discussion will be. So with that, I was going to have just each of the panelists provide some closing thoughts on the subject. So maybe Marco will go left to right. You get to go.
Well, I think going back to the theme of the panel, so AI and sustainability, there are a number of additional sustainability aspects that we haven't touched upon, right? So we talked a little bit about environmental sustainability. We don't want to pollute our orbits, for example. We talked a little bit about operational sustainability. In a new space ecosystem where we have many different stakeholders, then it becomes necessary to have operational processes and standardization in place in order to ensure interoperability of the different assets. But there are other sustainability aspects that I think are worth starting discussion about. Financial sustainability, still the space industry is heavily subsidized in a way by the government, but to have an healthy industry, you want to have a private capital. So how do we think, for example, a venture capital model of investment that is particularly tailored to space endeavors? Societal sustainability, of course, when you have many different stakeholders and limited resources, then the question is how do we allocate those resources? The United States have been on Mars, so does that belong that does mean that the places where they land, now they can plant a flag and say that those are the places where they can extract resources from. So sustainability in general as a topic has many different facets, and I will say almost all of them also affect the space industry.
Just to also be complementary to what already been said, as a university academic, I would like to also add the element in terms of education and workforce training. I think that's very important in terms of sustaining the sector in space and engage with the younger generation so that we have people actually are interested and passionate and can actually carry on and realize some of the visions that been mentioned by my fellow colleagues earlier in terms of, you know, what can be achieved, you know, with humanity having a long-lived presence in space, and, you know, both taking advantage of what is there as natural resources, but also returning back to the environment, and so that is beneficial to the society and our nature as a whole. So I think AI, in fact, is a perfect example because it, AI together with space does introduce quite some exciting emerging topics in terms of learning and education. And we're seeing also people, in fact, from this event, younger people getting excited about demos they've seen. I think that's a very good thing in terms of helping nurturing in the educational front, so that we have a sustainable inputs in terms of workforce and talents into the sector, that they can go in and pursue some of these emerging topics. So I'm very excited about it.
Thank you, Professor Gao. And just riffing off on something Dr. Gao said, there's also this element is as we start to get further, there are going to be missions when we can still imagine in a lifetime getting even to the icy giants. But beyond that, you need people to work on missions if you still, have limitations of lifetimes, that you think of getting to places that are beyond your lifetime. So that sustainability even comes in the fact that if we are going to get really farther out, creating a culture where there is motivation to do that. And I think that's another element of it as well. And I wanted to pass it on.
Yeah. Thanks. Try to summarize. I think Marco has given the variety of sustainability, which is important to see. And I would summarize from my viewpoint, since I'm from the DLR German Aerospace Center, Robotics Institute, so my background is robotic, not so much satellite imagery. Meanwhile, I have a lot of overview on these technologies. I would also point a little bit to your question. I think enhancing autonomous functionalities of the robots in space will bring us a lot of sustainability and will bring us a lot of cost efficiency and resource efficiency. So just referring to the example of life extension of satellites, where I have developed a system, which was even in a German space mission, the DEOS mission, Deutsche Orbitale Servicing mission, where we could service a satellite or we could life extend a satellite. So I think that are the very near future technologies which will work. And if you can make a satellite more operational for 5 years, ecologically, but also economically, how much impact that already does. This DEOS mission, the Deutsche Orbital Servicing mission, was the idea to have a kind of ADAC in space, which you can call over nations, which repairs satellite. And just referring to the Hubble reparation, where humans were involved, because I think the complexity of this operation was so hard to do. I would say in the future, maybe, it's your ambition, so it's not, that would be enabled by having more capable robots, having more AI functionalities, having more way of operation, teleoperation or full autonomous to do such services. So that's what my last words are in this.
Yeah, I agree. I think we talked about different types of sustainability. I would also add to what Armin was saying from operational sustainability. Today, the operations on other planets are slow, potentially inefficient, a lot of energy is needed. And I think it's hard to be in an AI type conference and not talk about OpenAI or foundational models. I think those methods, foundation models that are backbone of language models, they typically today work on virtual input like audio, text, language, things like that. But I think in the next 5 to 10 years, we are going to see a big shift where we are going to see foundational models that are physically grounded, meaning that they're going to be applied to physical system interacting with the physical world. And when and if that happens, I think that will also spill into space operations. If you have robots on a surface of Moon or Mars that are moving much faster, have manipulators doing the operations, construction, different things much more efficiently, that's going to change the way we operate in space, make it much more sustainable down the road. And it's exciting future. I think we are not too far from that. Hopefully, back to what Armin said, it's not end of century. I'm really hoping we see that long-term habitability in our lifetime in the next 2 to 3 decades.
Well, thanks everyone for coming for this, and all the panelists will be around. If you have additional questions, you can reach out to them and meet them in person. So thanks a lot.
Thanks.